Hey guys, this short video is going to take you through your actually this says 9.1, 9.2, but it's actually supposed to be 10.1, 10.2 homework. I'm not going over the entire thing. I'm not collecting it today. This is just a short video to go through some things that I think people are struggling with that I want to give you a second opportunity to look at before I'm going to go ahead and take it for a grade. Basically, and I think number 1 and number 2 are pretty straightforward, except number 2 on my answer key on online, I don't think I edited it. It should end up being 1/6, comma 5. So there's a mistake on that key there. Number 3 kind of ended up giving some people some trouble. So what I want to remind you, I'm going to go ahead and set it up with you here, is that you've got d is equal to the square root of, when you subtract, just make sure you go in the same order. So I'm going to pull from the second coordinate first. I'm going to do -5 square root of 2 minus x1, which is -4 square roots of 2. Notice I'm making use of parentheses around any negative that I'm inserting. Close parentheses squared plus open parentheses y2, which is 4 square roots of 5, minus y1, which is negative square root of 5, close parentheses squared. Now, you had to remember some radical rules to be able to do this one well, which is that if you have two numbers that have the same radicals, then essentially you kind of treat them as if they were variables. So that if the square roots of 2 match, then you can subtract the numbers or add the numbers in front of them. Now, the other mistake people make with distance formula is they forget to trail the radical the entire way through. Okay, so -5 square root of 2 minus -4 square root of 2, that's going to change to plus a positive. So that's going to end up being -1, or just a negative square root of 2 squared, plus 4 square root of 5 minus negative square root of 5 is going to also change to plus a positive 5 square roots of 5 squared. And then you can think about the square part in a couple different ways. I think the easiest is just to think about that term times itself. So negative square root of 2 times negative square root of 2 plus 5 square root of 5 times 5 square root of 5. And then go ahead and simplify. So negative square root of 2 times negative square root of 2 is going to be a positive. The square roots cancel, so you're just left with a positive 2. Plus, for this one, these rules, you get to multiply the 5's out front. So 5 times 5 is 25. And then the square root of 5 times the square root of 5 is 5. So that's going to be 25 times 5. 25 times 5 is 125. 125 plus 2 gets you to the answer, which is 127 units. Again, think back to geometry and how picky I'm sure your teacher was about units. In this case, in finding distance, if they don't give you anything, just go ahead and put units, if they don't say inches, centimeters, or whatever. Number 4, find the perimeter of the triangle. You're looking for the length of all three sides. So for this one, you had to find the distance from A to B, the distance from B to C, and the distance from A to C. So that's what you should have been doing there. The only one that was kind of tricky was, I believe, B to C. You ended up with the square root of 68 as your distance. I want to remind you that you have to give your answers as simplified radicals. So the biggest square number that goes into 68 is 4. So you would break this up into the square root of 4 times 17. The square root of 4 is 2, so then you would end up with 2 square roots of 17. And then I believe the final answer for that, if you didn't get to check your answer, would end up being 18 plus 2 square roots of 17. For the next group, again, the directions were wrong. It said write each equation in standard form. I want them in vertex form. Then identify the vertex axis of symmetry direction of plane of the parabola. So let's do number 5. Remember, vertex form is of the format y equals a times x minus h squared plus k. So the thing I want you to notice is that there's one x term. If you look at number 5, there's an x squared term and there's an x term. So whenever you see two of them, then that means we need to complete the square in order to condense those, if you will. So when we complete the square, remember we care about an initial a value of 1. So we need to factor out this 2. So when I factor out that 2 in the x squared term, I'm literally left with x squared minus 6x. Here's the thing, when we complete the square, we need a new c. I don't care about 19. I don't need to try to factor 2 from 19. That's just going to make it complicated because 19 is just going to hang out over here by itself. That is not a part of the completing the square process. We are looking for a new c completely. You leave this c alone. To find the new c, we do b over 2 squared. In this case, b is negative 6 over 2. Negative 6 over 2 squared is negative 3. Negative 3 squared is 9. Now, this 9 is being affected by this 2 that's on the outside. So technically, I just put 18 in this problem. So if I put 18, you have two choices. Choice number 1 is if I put 18 on the right side of the problem, then I can put 18 on the left side of the problem, right? As long as I keep it balanced. But the other thing to do is if you're going to add 18 to the right side, you can also just subtract 18 from the right side because then it's essentially like adding 0. Simplify it further, you end up with y is equal to 2 times, the trinomial becomes x minus 3 squared, and then 19 minus 18 ends up being plus 1. So here's your equation in vertex form. The vertex for this one ends up being 3, 1. The axis of symmetry flows straight from the vertex. Remember, in this case, it is going to be the x value. So literally write the equation of a line. Don't put that the axis is 3. You must put the axis as x equals 3. The direction of the opening of the parabola, y is first, which means this parabola can open up or down. And since 2 is positive, this a value is positive, we know it's going to open upward. Okay, let me get you started on number 6 too, because I know that was kind of tricky. For number 6, it's the same idea as we did for number 5. I need to complete the square. I want my a value to be 1, so I'm going to factor out a 1/2. When I factor out a 1/2, I'm left with x squared. And where people are getting confused is factoring out a 1/2 from 3. So you can think about it in two different ways. You can think about it as 3 divided by 1/2, which divided by 1/2 is the same thing as multiplying by 2, which would end up being 6x. Or just think about, okay, when I end up distributing this, 1/2 times x squared gets me 1/2 x squared. 1/2 times what gets me back to 3x, which ends up being 6x. So if you struggle with figuring out that part, then just try to go guess and check and go backwards. Again, plus a new c, and then you're just going to leave that 1/2 alone. Don't factor anything out from that 1/2. This old c does not have anything to do with the new c. To find the new c, b over 2 in this case will be 6 over 2 squared, which is 3 squared, which is again 9, except this 9 is being multiplied by 1/2. So that's going to be 9 halves or 4.5. So if you add 9 halves to the right-hand side, you either add it to the left-hand side or you just subtract it again from the right-hand side. So then you end up with y is equal to 1/2 times, the trinomial becomes x plus 3 squared, and then 1/2 minus 9 halves is negative 8 halves, and negative 8 over 2 ends up being negative 4. So this ends up being that final answer in vertex form. And then from there, I'm confident you can get the vertex and axis of symmetry in which direction it opens. Let's jump down to the next group of questions, particularly number 9. Number 9 looks a little bit tricky because it doesn't seem to have the same structure as the others. First of all, I want you to notice that x is first. If x is first, that means this parabola is opening either to the left or to the right, but because there's a negative a value, we know that this is going to open up to the left. So if you recall, parabolas that open up to the left or right have the equation x is equal to a times y minus k squared plus h. So remember, the x and the y switch, and the h and the k also switch. Well, the only difference between what I just wrote here in red and the problem itself is that there's just no parentheses around a y, and then there is no k value. So essentially, you could think about this, if it helps you, as x equals negative 1/3 times y minus 0 squared plus 1. And if you think about it that way, then that means k is equal to 0. So then your vertex is just going to end up being, remember, h comma k, h is 1 comma 0. So there's your vertex. Vertex is at 1, 0. Directions say graph it with at least 3 points, one which must be the vertex, which we've already found. To find 2 other points, I think my answer key may have been a little off, which is why this also may be tricking some of you. But to find 2 other points, because of the orientation of the parabola, you want to plug in y values and then substitute to get the x values. So first of all, if this is opening to the left, I know the axis of symmetry is the horizontal line at 0. And so it's good to pick one coordinate below or above, and then do the symmetric coordinate below. That's going to make the parabola as well. So here's the deal. I could plug in 1, right? If I plug in a y value of 1, so notice my table is going to be a little bit backwards. If I plug in the y value of 1, that's going to be 1 squared, which is 1, times negative 3, or sorry, times negative 1/3 is negative 1/3, plus 1 ends up being 2/3. So you could graph the point 2/3, comma 1. And then that other point would end up being 2/3, comma negative 1, because it's going to be symmetric over that axis of symmetry. If that makes you uncomfortable, plug in a better y value. Particularly, try 3. If you try a y value of 3, when you plug that in, 3 squared is 9, negative 1/3 times 9 is negative 3, and then negative 3 plus 1 is negative 2. So then if you plot the coordinates, negative 2, comma 3, it ends up being actually, just kind of a lovely one on the grid itself that you're not having to estimate. So you only needed 3 points, but I gave you 5 here. And I'm okay with the one that's 2/3 as long as you are. If that makes you uncomfortable, pick another one. There's no rules there that you have to pick a certain one unless specified. Okay, there's a little bit of hopefully help on the front side. On the back side, I just want to touch base on 11 and 12 very quickly because these give you a scenario, and I give you a graph for a reason because I want you to graph the scenario. Number 11 has a vertex at 0, negative 4. I'm going to draw that point, label it V. I also know the focus is at 0, comma, negative 3 and 7/8. So here's the deal. That's going to be hard to graph, but the point is it is inside, just above that vertex is your focus. If you remember from last class, I stressed a bunch of times, the focus is inside of your parabola. So if the focus is inside of the parabola, I know the parabola is going to open upward like this. So I know it's going to have a positive a value. When I write the equation for a parabola, it's opening upward. I know it's going to have the form y equals a times x minus h squared plus k. So the deal is, if I know the vertex, I already have h and k. I know y is equal to, I don't know a, so I'm going to leave that there. X minus h is 0 squared, and then plus k is just minus 4. So the only thing that I need to figure out is a. Well, that's where the vertex comes into play. The vertex and the focus, if you remember from last class, are C units away from each other. So again, it's kind of too hard here for me to zoom in and show you exactly, but if the vertex is at negative 4 and the focus is at negative 3 and 7/8, then these are 1/8 away. That means C is equal to 1 over 8. And then again, if you remember by definition last class, we defined C as 1 over 4a. So then if you set these guys equal, if you set 1 over 8 is equal to 1 over 4a, and then you're trying to get a by itself, you can do this in a couple of different ways. You can multiply both sides by, well, actually, if I just want these to match, I can just kind of logically say, okay, I know a must be 2. Because if a is 2, then 4 times 2 is 8, and then 1/8 equals 1/8. You can solve it algebraically as well. If a is equal to 2, I plug that in. I end up with y equals 2 times x minus 0 is still just x. So that's going to be 2x squared and then minus 4. Number 12 is a similar idea, except instead of giving you the focus, I give you the directrix, but you're still going to make use of the variable a. Lastly, number 13, two parabolas have a vertex at negative 3, 1. Negative 3, 1. Vertex. They contain the point negative 1, 0. Write an equation to represent each parabola. So you have two options. I recommend you drawing two different graphs, but essentially here's your two options. If that is the vertex points, you could have a parabola that opens downward like this, or because of the nature of conic sections, we are allowed to have non-functions, and we can have a parabola that opens up to the right with that vertex. So your job is to write the equation of, in my picture, the green parabola and the red parabola. 14 through 17, was a spiral review. The only one I want to talk about briefly is number 16, because a couple of chapters ago when y'all took this on your test, it was a big struggle. I want to remind you, you could do change of base if possible. but it's not possible. You can't change 7 and 13. So in order to get the exponents down, you could take the natural log of both sides. When you take the natural log of both sides, those exponents, x plus 2, drop down out front. So it ends up being x plus 2 times the natural log of 7 is less than or equal to 5 minus x times the natural log of 13. And then from there, you will distribute and you will try to get your x's by yourself. So if you were kind of stuck on that one, that gives you a little bit of headway, hopefully, in making some progress there. So I'm not grading this today. I want you to take what I've given you here, take these tools, check the answers on Google Classroom, and come back to class, hopefully next time with a better grip around these types of problems. If you're still struggling, shoot me an email. Come see me in tutorials.